Students, so we are just want to find the steps to design an analog Butterworth filter. So now we are proceeding to find out the analog Butterworth filter. For that we just want to understand what are the steps. What are the steps is needed to design the Butterworth filter. So this is what actually first thing what we need to find. We need to find the order of the filter n. So we know that. What is the n value just now we found? N is greater than or equals to log of 0.1. 10 root of 10 of 0.1 alpha s minus 1 by 10 0.1 alpha p minus 1. So this value we will take it and we will find out the value for it. After knowing this alpha s and alpha p, we will find the frequency in the stop band and frequency in the pass band. We will put it and we'll get the value of n. Next thing, after knowing this thing, what we'll find? We will find the second step. What is the second step? Find the transfer function. So what is the transfer function we have? We have h of s. H of s we need to find. How do we find? That depends upon your order of the filter. So that order of the filter is what? That is nothing but here we will add that we will substitute in this and we will find out the value. So how do we find? It is depends upon your critical value. What is the assumption here? Critical value, what we need to assume? 1 radian per second. So that is a critical frequency. The third step is about the h of s polynomial for different orders. So what I am doing, I am using different polynomials for different orders. So first thing what I am using for the order. Suppose you are getting n. So n value, suppose you are getting first order. So what is a polynomial? This is polynomial for denominator. So I am writing the polynomial value. Polynomial for denominator means whatever the transfer function we are writing, for that what is the value. So suppose you do have first order. For finding the first order, what is the polynomial we do have? We had it as first. This can be 1 order, it can be 2 order, it can be 3 order, it can be 4 order. If you had first order, the polynomial needs to be s plus 1. Directly you need to remember these values. Okay, so if you are getting n is equals to 1, then the polynomial needs to be this one. Second part, if you do got n is equals to 2. So this, how do we get this? If you get n is equals to 2, we need to use s square plus root 2 of s plus 1. This is our second polynomial. So see, is second order means the square of it should be second order. So that's the reason it's s square plus root 2 of s plus 1. If you are getting third order, for the third order what we'll do? We'll try to write down the factors based upon its function. So how do we write? We'll write s plus 1 into s square plus s plus 1. This is a formula you need to remember. Okay, so for this one if you multiply, see, s into x square, it will be s power 3. That means it's which order? It is a third order. So like that we will find first order, second order, third order. Next, if you do got n is equals to 4. So for writing the 4, there is a constant value. What is the constant value? S square plus 0.76537 of s plus 1 into s square plus 1.8477 s plus 1. So for the fourth order we will substitute. Likewise we do have more values. So till now you remember the values for your polynomial needs to be this. For the first order it needs to be s plus 1. For second order it is s square plus root 2 s plus 1. For third order it is s plus 1 s square plus s plus 1. For fourth order s square plus this is 0.76537 s plus 1 into s square plus 1.8477 s plus 1. These are the constant value to find out the polynomial. So now we got the h of s, where omega c we assume as 1 radian per second. Next criteria is that we need to write, we had the omega c, right? So we assume it. Now next thing, for next step what we need to write? We have to write omega c. We need to find what is omega c. That is nothing but cutoff frequency. What is the cutoff frequency? So omega c is given by, if it is pass band, omega p by 10 per 0.1 alpha p minus 1 whole power 1 by 2n. Okay, that n indicates order of the filter. Or it can be, if it is in pass band, we will put the value for pass band. If it is in stop band, omega s by 10 power 0.1 alpha s. It's a cut of attenuation in stop band. Minus 1 whole power 1 by 2n. Okay, so if it is in pass band, we will put the value for pass band. If it is in stop band, we can put the value of stop band. You can take any one of them and you can find out the value for omega c. Then last step is to write this h of s. This is our step 1. We found the order. Second, we write the transfer function. Third, we wrote the polynomial. Fourth, we found the omega c. Fifth step, this h of s, we will modify it. This is the fifth step. In fifth step, what I am doing? I am writing HA of s. How I get the HA of s? H of s answer I'll divide by omega c. H of s in the sense whatever the s answer is there, not HA of s. S answer, wherever s is there, no, there s I need to divide by omega c in h of s. If I'll do it this thing, I can find out the complete transfer function. That is the question they can ask you to find or design the Butterworth filter. So Butterworth filter for finding the transfer function. So what is the first step? First step is to write or find the order of the filter. Second step, find the transfer function by taking these values. If you are getting the answer as suppose n is equals to 1, then this is the first polynomial. N is equals to 2, second, third, fourth. Likewise 5, 6 also. When we use it, we'll show you the values. Next, critical frequency. We can get in with this one or with this one. Then we will find the transfer function by considering omega c. Previously what we assume omega c, it's 1 radian. Now we got omega c. That omega c we will substitute in the formula and we will find out the value for cutoff frequency omega c. So for cutoff frequency, what I am doing, I just want to find the function of it. So for finding the function, I need to find the value of this, then I can put it in the formula. So let us see one problem based on these steps, then you can understand how it can be useful for designing the problems. So we'll take one problem, students. So they gave one question, given the specification of, so we had one question, so that one I'm writing. First they gave one question. So they gave, given the specification alpha p is equals to 1 dB, they gave its specification alpha p is equals to 1 dB. Then alpha s is equals to 30 dB. Omega p is equals to 200 radian per second. Then we do have omega s. Omega s is given as 600 radian per second. So determine the order of the filters. The question is, by using this we need to determine. What we need to determine? Determine the order of the filter. So that is a question. So that is the first question, number 1. So here they gave what are the things they mentioned in the question. They gave the attenuation in pass band, attenuation in stop band. Here frequency in pass band, frequency in stop band. What is the question? What is the point they asked to find? They asked to find the order of the filter. So how do we find order of the filter? To find the order of the filter, we know what we know. N greater than or equals to log of. So what is the log of? 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 whole power 1 by 2 or root. So root is nothing but 1 by 2 I can write. By, again it is logarithmic of, so this is alpha s, right? So frequency of stop band by frequency of pass band. So this we will do it. So we had alpha s, alpha p, omega s, omega p. We can take that value and we can substitute. So in order to, since if you are substituting, it will be like complex thing. So what I'll do it, I'll find this factor separately, then I'll put the value in the order of the filter. So what I'm doing, I'm considering. So let us consider. So what I need to consider, 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1. This value I need to consider. So what is alpha s? I do have 30. So 10 power 0.1 into 30 minus 1 by 10 power 0.1 into, what is alpha p? I do have alpha p is 1 minus 1. So if I'll substitute this value in the calculator, I'll take the calculator I will substitute this value in calculator. So I can directly put it this thing in calculator. I can find the value. So if I am putting this value in calci, so what I am getting? So 10 power 0. So we do have 0.1 into 30. I can write it as. I'll further simplify so that it will be easy. So 10 power I can write. Point n will be cancelled. It is 10 power 3 minus 1 by 10 power 0.1 minus 1. So 1000 minus 1 is anyhow 99. 999 I can get here by that one. If I'll put it in the calculator, what I'll get? I'll get 10 power. So 0.1 alpha p minus 1 with this one whole root. So it is root here and root here. I'll put it. So I'm getting 62.13. So I'm getting 62.115. This is the factor. For this numerator factor we found with root. I put the root also, right? So numerator we got. Now I need to find the denominator. Denominator is easy only. So what is the value? Omega s by omega p. What is omega s? Here is 600 radian per second. Next omega p is 200 radian per second. So 6 by 2 it is what? 3. So we got 3. So now I can put this thing in. This is your equation 1. So n is greater than log of, what is this value? 62.115 divided by log of, so what is the second value we got? 3. So if I'll put this in calculator, what I'll get? So log of 62.115. So log of 62.115 divided by log of 3. So I'm getting 3.758. So the answer for this will be 3.758. So what we got, students? So we got n. So what is the n answer? N is greater than or equals to 3.758. So this is n value. We need to round off this one to the higher integer. So what is the higher integer? 3.7 higher integer is what? N is equals to 4. So your answer for this particular problem would be fourth order of the Butterworth filter. So how do we have solved this thing? We have taken alpha is alpha p, this whole factor we considered, we found this value. Secondly, in denominator we took that particular factor, this one, and we put this value. So we got this one as 3. These two we substituted in our order of the filter in equation 1. So n is greater than or equals to log of this divided by log of this one. If you divide it, you got 3.758. So this is 3.758. Always n is greater than or equals to 3.758. So we need to take always round off this integer into highest value. So what is the highest after 3.7? Highest integer value is 4. That indicates it is the fourth order of the filter. So this is nothing but, so we can conclude by solving this question that the given specification is for the fourth order of the filter. So students, we do have second problem. So determine the order and pole of the Butterworth low pass filter which have 3 dB attenuation at 500 Hz and 40 dB attenuation at 1000 Hz. So we gave this question. In this, they did not mention which is a pass band, which is a stop band. So for the first thing, what you need to keep in your mind, this is which type of filter? Low pass filter. Low pass means it will allow the lower frequency component, it will attenuate the higher frequency component. That means this has become its lower frequency, right? 500 Hz is lower frequency. 1000 Hz is a what? It's a higher frequency. So which they should allow? They should allow this part. So that means this has become now pass band. This has become now stop band. So is it clear? So what we are doing? We are making low pass filter. So what is the low pass indication? It's allow lower frequency components. It will attenuate higher frequency component. For that, what I'm doing? I'm taking, this is my pass band, this is my stop band. So what I'm doing, I need to write. So what is the value I do have? Alpha, what? Alpha p is equals to 3 dB and omega p. Omega p is how many? 500 Hz. Likewise, I do have Next thing, alpha is stop band. It is 40 dB into omega s. It's what? 1000 hertz. So, but our frequency needs to be in radian per second. So, in order to convert this hertz into radian per second, what I'll do it? I'll multiply with 2 pi. So, this thing I need to convert into angular frequency. So, for that, what I'm doing? I'm multiplying 2 pi into 500 radian per second. So, this I multiply with 2 pi. Similarly, here I can multiply 2 pi into 1000 radian per second. So, what is the value of this thing? 2 pi into 500, it will be 1000 pi radian per second. This is what? 2 pi into this, 2000 pi radian per second. So, we need to find out the order and pole also. So, this is one more thing, pole. When explaining the starting one, I have explained you about poles also, zeros and poles. That also we need to find out, and we need to find the order also. So, for finding the order, what is the value we know? So, we know that order n is greater than or equals to log of 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1. This is with log factor divided by log of omega s by omega p. This we note with root. Root is nothing but 1 by 2. So, first thing I'll find upper factor, then I'll find lower factor, then I'll substitute in the main equation. Suppose this is your equation 1. What I'm doing, I'm substituting this n value. I'll write here in middle so that it will be easy for us to understand. So, this is your n greater than or equals to this whole factor. So, I'm considering. So, now let us consider. What we need to consider? 10 power 0.1 alpha s minus 1 by 10 power 0.1 alpha p minus 1 whole power 1 by 2. This numerator and denominator also. What is denominator? Omega p by omega s by omega p. So, this is omega s by omega p. This 2 also we need to substitute. So, we do have this thing. I can put it 10 power 0.1 alpha s. What is alpha s? It's 3. In alpha s is 40 minus 1 by what is alpha p we had? Alpha p is 3. So, 10 power 0.1 into 3 minus 1 whole power 1 by 2. This I'll put it in the calculator. I'll take the calculator. I will put this value in calculator. I will find out. So, this we got. Later on I'll do it. I'll substitute this omega s by omega p. Omega s we do have is 2000. This is 2000 pi by 1000 pi. So, pi and pi gets cancelled. 2000 by 1000 is nothing but 2 we got. So, this is what I can write. I can further simplify 10 power is 4 minus 1 by 10 power 0.3 minus 1 whole power 1 by 2. So, this value and this value. If I'll divide, I'll get the order. What is the order? N greater than or equals to log of this whole answer. 10 power 4 minus 1 by 10 power 0.3 minus 1 whole power 1 by 2 by log 2. So, this I directly substitute because I do have value of this thing. Directly if I put in the calculator, I'll get it. So, what I'm doing, I'm directly putting in calculator. So, log of, so what is the value log of? 10 power 4 is nothing but 10,000. So, 10,000 minus 1 divided by, so 10,000 minus 1 divided by 10 power 0.3. So, 10 power 0.3. So, I'll get this by log 2. So, this whole factor whole power 1 by 2 divided by log 2. If I'll do it, divided by log 2. So, what is the answer for this? The answer is 6.6. 6.6 enough. So, after the point you can take one value. So, we got n value. What is n value we got? So, I can write n greater than 6.6, right? What is n greater than 6.6? I can write, it's round off. This thing we need to round off to nearest n highest integer. So, after 6.6, what is the next value we can write? 7. So, n is equals to 7. That means it is which order? It's 7th order. So we found order of the filter. So till now what we have done, student, we have the attenuation in stop band, attenuation in the pass band. We got both the values, we put the values, and we will find out the what order of the filter. So next thing what we need to find, we need to find the poles. So first you noted down this thing, I'll go for pole. So till now we got, students, so order of the filter. Next thing we just want to find out the pole. So to find the pole, what is the order we do have? We had order is 7th. So we need to write the point over there. It is a 7th order. So after knowing the 7th order, what is the next criteria is that we need to get what? We need to get the pole. So what is the pole value we can write? Since we had how many order? What is the order of this one? So first thing, make a point here. You will mention that round off. So round off to nearest highest integer. Okay, so we have to round off this thing to nearest highest integer. After rounding off to this particular thing, we can get the what? Second bit. We do have to find out the pole. So pole, what I said, pole is given by what factor? E power j phi k. So this is nothing but your s. You're converting that into s particular factor. We need to write the poles for it. In which domain I'm writing? In k, sk. Okay, so sk is equals to, here I'll write sk is equals to cutoff frequency omega c into e power j phi k. So omega c, what we are assuming, omega c is equals to 1 radian per second. So we got sk is equals to e power j phi k. Okay, what is phi k? Actually it is nothing but phase difference. How do we find phase difference in any particular filter? Pi by 2 plus 2n minus 1 2k minus 1 by 2n of pi. This is the formula to find out the order of the filter. So we need to substitute different values of k. What is the values of k starts from? K value should be 1, 2, 3, so on. Maximum value for the k will be 7. Why it is 7? Because we got order is 7. So substitute here, we get phi 1, phi 2, phi 3, like this we can find out. So we will find first, if you substitute k is equals to 1 in this is our formula. For what? This is what actually, this is nothing but pole. So we want to get the pole. So you can stop here also, or else if you want to substitute, you can substitute in this, you will get the phi 1 value. So phi 1 is equals to how much, students? So pi by 2 plus 2 ones are 2. 2 ones are 2. 2 minus 1, 1. So it is what? 1 by 2 into 7 of pi. This is what? Pi by 2 plus pi by 14. This is a phi 1. Similarly, phi 2. What is phi 2? Pi by 2 as it is. Wherever k is there, we need to substitute 2. Plus 2 2s are 4. 4 minus 1, 3 pi by 2 into 7. So pi by 2 plus 3 pi by 2 7s are 14. Right? Next phi 3. Likewise, I can find for phi 7. So what is phi 7? Pi by 2 plus 2 into k. K is how much? 7 minus 1 of 2 into 7 pi. So I can write pi by 2 plus 2 7 are 14, 13 pi by 14. That is a phi 7. So in the exam it is not asked. If they ask, we will find, only they said to substitute. What is the substitution? K value. What is the k value? Varying from 1 to 7, because we got the order is 7. So we had this formula for finding what? For finding the poles. If they ask the Butterworth poles, they ask to find Butterworth folds or Chebyshev fold. For any kind of poles, we need to use this particular formula to find out. So what is the thing we had this thing? Sk is equals to omega c e power j phi k. This is a formula. We had this omega c, what we are assuming, 1 radian per second, because in the question they did not ask to find critical frequency. If at all they ask, then we will find critical frequency formula. So they did not said, that's the reason we are putting 1. So e power j phi k. So phi k is this thing. So phi is what actually k value varying from 1 to 7. We substituted, we got this thing. So this is the way we got order of the filter, and we will find what? We will find the phase. That is nothing but the poles. So we found the poles as well as we found the order of Butterworth low pass filter. So this is about the today's class. In the next class we will see complete how do we design transfer function for given Butterworth filter. Thank you.